Now the question wants you to find the current in this part. So what you can do, one of the ways to solve, right, is to combine these two first. But how do I combine them, right? So some people get confused. Like, these two in parallel, what about this, how should I combine them? Should these two be in parallel with this, or should this be in parallel with this? So how do I see that? Now the idea behind current and whether it's series or parallel is actually very predictable. You just have to see how the current behaves, and then we will know which resistors are in parallel and which resistors are in series. Very simple. Now the current will come up from the positive side. Can you see there are two junctions that can flow? If both sides has resistance, it will split. The current will split. When it won't split is, let's say you have another wire which has totally no resistance. And then when the current comes here through three possible paths, here got resistance, here got resistance, here got no resistance, and then the entire current will flow through here and bypass these two. So that is what we mean by shorting. So that means short circuit means it doesn't want to pass through any of the resistors because there's a path of zero resistance. And then the current will flow this way. It means these two resistors are shorted. You understand? But not the whole circuit shorted out because it still has to pass through a resistor. But these two resistors are considered to be shorted. But in this case, because both are resistors, it will split. How it will split, I was mentioning to you before. The higher the resistance, the smaller the current. The smaller the resistance, the higher the current. So that the PD here and PD here must be the same. Okay, but I'm sidetracking now. Let's come back to the question. So here it will split, and then here will join back, right now. So if the current splits and joins back, it means that these two are in parallel. So you can actually draw them in parallel. So what is the total resistance in parallel? We can calculate. Then it will join with this in series because it no longer splits here. Understand? So these two in parallel, what's the total resistance? So 1 over 6 plus 1 over 3 equals to 1 over R, and R you get as 2. So these two resistors I replace with a single resistor 2 ohm, correct? Which is in series with this 2 ohm resistor, right? So what is the total current in this circuit? The total voltage is 12 volts. The total resistance is 4 ohm. So the total current will be 12 over 4 ohm, which is 3 amperes. Agree now? Now these 3 amperes will then split between these two. Alright, some people can see it. Since the ratio of resistance is 2 to 1, then the ratio of current will be 1 to 2. So if it's 3 amperes, this will take 1 ampere, this will take 2 amperes because these smaller resistors. But if you cannot see, you can still calculate. I'll show you how to calculate. If this is 3 amperes through this resistor, so what is this PD? 6 volts, right now? So if this is 6 volts, then definitely each of these resistor also 6 volts because these two in parallel makes up this. So the PD across this equals a PD of each one. So if this is 6 volts, this is 6 ohm, the current here is 6 volts, divided by 6 ohm, you get 1 ampere, same answer. But of course, if you can see that the ratio of current in these two is in opposite ratio to your resistance. So since it's 6 to 3, that means 2 to 1, current will be 1 to 2. So it's 3 ampere, so just nice, 1 ampere, 2 ampere. So you can also get 1 ampere. You see that? Now, whenever you connect like this, right, how do I know which is in series with who and who is in parallel? Very easy. Can you see the current will enter through, let's say, one side. You can treat this as positive or this as positive, it doesn't matter. Just for the example, I treat this as positive. When current comes in, can you see it will split? So when the current splits to here and here, this and this are considered in parallel because it splits. So I can draw the 10 and 10 to represent these two. Do you understand? Because it's splitting. Then the current that passes through this will continue to 2 more resistors without splitting. That means this 10 ohm will continue to another 10 and another 10 ohm without splitting. Then only it joins back. So it joins back with the bottom. Can you see that? So now can you see how you can redraw it so it's easier to see? So question is, 10 ohm is in parallel with 30 ohm. Now didn't we say that the total resistance in parallel must be smaller than the smallest resistor in parallel? So that means this is 10, this is 30, your total resistance must be less than 10. So it can be either A or B lah. But since 30 and 10 is not so much difference, so the total resistance will be slightly more than 10, so it will be B lah. But you can test it out by calculating lah. So 1 over 10 over 1 over 30 plus 1 over 30 equals 1 over R. Then you get RS at 1.5. So answer is B. Now, firstly, this question is talking about using an ohmmeter to measure the resistance. So your ohmmeter can be something like the multimeter here, which we use in the lab, remember, to test your wires. So you set it to ohm setting, that means to measure resistance, and then you connect across a circuit. Now, I just want to recap how an ohmmeter works. So the ohmmeter will use the built-in cell inside here. That means you put a cell inside your multimeter here or ohmmeter here. And it will make use of another resistor within your ohmmeter. There's a built-in resistor to prevent short circuiting. So what will happen is, you can imagine there is actually a cell. Oops. You can imagine that there's a cell connected to a resistor. So this is inside your ohmmeter. So these are your two terminals that you connect. So these two terminals here are your two terminals here. Okay now. So what will happen is, once you connect to these two, current will come out from one of the terminals here, which is the positive side here, and then go through the whole circuit and come back to the negative lah. Then come back to here. Understand? So by knowing the current that is flowing through this circuit, okay, and the resistance in here, and also the voltage here, you can figure out what is the resistance in between the 2 points. Do you understand? Because voltage it knows, the current in the circuit it knows, and this resistance it knows, so you can figure out the resistance in the circuit. So then the question is, based on the meter readings here, you're supposed to figure out which lamp is faulty and what kind of fault it is. So let's talk about what you should get and what you are getting. Okay, so now let's look at the first one. Open, open, open. So if all the three switches are open, you connect your ohmmeter like this. The current comes out from here. Can it go anywhere? Because all broken one. Can it move into any of this? So what will happen is, the ohmmeter will detect that no current can flow. If no current flows, it means that the resistance is infinite, too big. Understand? Which is logical. Next one, closed, open, open. So if this is closed, this is open, this is open, then current will be able to flow through here and come back. Can you see now? It comes out and flows through here and comes back. Can you see that? So that means your ohmmeter will measure this resistance only, because it only passes through this and comes back. So this shows you 15 ohm. That means this is a clue telling you that the resistance in A should be 15 ohm. Alright, next one. Open, closed, open. So open, closed, open. So current will come out from here, pass through this and come back. So can you see the circuit here? This way. So that means these two are in series or parallel. Since the current comes here and also here and comes here. Does it ever split? Series. So if one resistor or one lamp is 15 ohm, two lamps in series must give you 30. So are you getting 30? So that means A and B are not faulty. But the third one, open, close, close. So open, close, close. So current will now come out here and it will split to 2, because these two are closed. So these two current will split and join back. That means these two are in series or parallel. So 15 and 15 ohm in parallel must give you total of how much? 7.5. So 7.5 in series with 15, because this is series with 15 is how much? 22.5. But what are you getting? 15. So something is wrong with C. Do you understand? So which is a faulty lamp? C. But what fault? So now there are two possible faults. One is a broken filament. We call it open connection. Broken filament open connection means this filament broken. So when the current tries to flow, it cannot flow. So the current will only flow through here. Do you understand? But if current flows through only this, then these two will be in series. So total you should be getting 30 right now. But you're not getting 30, you're getting 50. So this is not an open circuit. But short circuit means you can imagine there's a stray wire that connects the two terminals of your lamp and bypasses the filament. That's called shorting. That means this lamp is shorted, the current just flows bypasses your lamp. Do you understand? That's called shorting. So when the current comes to here, passes through lamp A, and you realize that this has shorted circuit, that means there's no resistance, and this side got resistance, do you think current will split? No, right now, because when one side has no resistance, one has resistance, then all the current will bypass this and just go through here. So by shorting this lamp, you will also short this lamp as well. So the current will come out from here and bypass everything and come back. That's it. So how much will your ohmmeter read you? 15. That's how your 15 is. So therefore, conclusion is the nature of the fault is shorted. So you can say faulty lamp C, nature of the lamp shorted, as in SHORTED. Now then, the last part of the question asks you, why it is advisable to test the circuit using an ohmmeter that causes negligible current rather than with a power supply. Now your ohmmeter, I told you, has a built-in resistor here, which is very large resistance. So even if, like, you know, remember in the lab I told you to test your wire by connecting these 2 points? No problem, even though you are trying to short the ohmmeter, but because the resistance here is very, very high, there's still a small current flowing. So nothing will spoil. You understand or not? So they say, why is it better to use an ohmmeter here to test the whole circuit rather than using a power supply? Because if you don't know this method, most people, if I told you, oh, there are 3 lamps here, no, one of them is damaged, can you test which one? The easiest way you will do is you connect to a power supply and then you switch on and off. Which one will off, which one will never turn on, cannot turn on, is spoil lah. Correct or not? That's the easier way of testing. Why you want to measure resistance to check right now? You just turn on and off. Okay, why this lamp never turns on? That is spoiled. Okay? Now, why we cannot do it? Now, in the beginning, you didn't know which lamp was damaged. It could have been A right now. It could have been A. Now, if A is shorted, I'm just saying, hypothetically speaking, if A is shorted and we did this combination, right, the second one, close, open, open. So what will happen is, when you close the switch here, and this is shorted, and we are using a cell here, a power supply here, so current will straight come out from the positive, no resistance come back. So that means your supply here will be shorted. That means everything just bypass, everything come back to your supply. Now, is this dangerous? Yes, because the supply will have a very small amount of internal resistance, which causes a very large heating effect because the current is very high. So what will happen is the supply will overheat. Okay, so they will damage your supply. Okay, so the answer would be to prevent the large current passing through the supply, if A is shorted. Okay, so continuing the part C, what is the resistance of one of the lamps as measured using the ohmmeter? Just now we said it is 15 ohm. Now, each lamp is marked 6 volts, 0.2 ampere. Calculate for one of the lamps operating at normal brightness. So why is this normal brightness? Remember, this rating here is for under normal operating condition. That means you must be on and working normally. Then you will have this rating 6 volts or 0.2 ampere. So which formula do you want to use? So we can use the formula which is R equals to V divided by I. So 6 divided by 0.2, which gives you 30 ohm. Right, so next part, find the power dissipated. So that is also quite straightforward. Since you know the V, the I, the R, you can actually use any of the formulas. You probably want to use P equals to VI because you don't have to square anything. So 6 times 0.2, which is 1.2 watt. Okay. Now, comment on your answers to C and D part 1. Now, remember in part C, which is the resistance as measured at ohmmeter, the resistance of each lamp was 15 ohm, right now? But now, the resistance you calculate here is 30 ohm. So how come? Based on the rating, the resistance is 30 ohm, but when you were testing it using an ohmmeter, it only showed you 15 ohm. So why? You see, when you're using your ohmmeter to measure resistance, is your lamp on or off? It is off because a tiny current passes through, which is not enough to light it up. It's just to measure resistance only. So it is off. But when you use this rating to calculate the resistance, is it on or off? It's on. And when the lamp is on, it becomes hotter, remember? And when the lamp becomes hotter, what happens to the resistance? It becomes higher. Therefore, when you're using ohmmeter, it is cold, that's why it's 15 ohm. But now that you turn it on, it is hot, the resistance increases to 30 ohm. Can you understand that? Alright, so can you write down the answer? The resistance of the lamp increases when temperature increases. Okay, the resistance of the lamp increases when temperature increases.